for this unit goes back to something that you know very well. It deals with the Pythagorean theorem. We're going to be using the Pythagorean theorem a little bit differently, though, today, and we're going to be using the Pythagorean theorem to classify a triangle. So we already know that if a squared plus b squared really does equal c squared, then our triangle is a right triangle. That statement is only true if the triangle is a right triangle. Now, if by chance the a squared plus the b squared turns out to be bigger than c squared, what that means is that c squared got smaller, so c got smaller, so this angle got smaller than the right angle it used to be. So that means that now our triangle will be an acute triangle. If the a squared plus b squared turns out to be less than c squared, then that means that c squared got longer, which means that angle c got bigger than the 90 degrees it was originally. And our triangle is an obtuse triangle. So we're going to be using these three things to help us tell what kind of triangle we have. So if we take a look at the examples that we have here, they say, first of all, determine if you can actually have a triangle for part A, and part B, if so, tell what kind of triangle it is. So earlier this year, we talked about a rule that says that you can only have a triangle, which is our question, if the small side plus the medium side turns out to be bigger than the large side. So for us, in this one, is 7 plus 14, the small plus the medium side, bigger than the large side of 16. So 21 is bigger than 16, so my answer is yes, this can be a triangle. If I'm classifying what kind it is, it means I take the a squared plus the b squared, and I see how it's related to c squared. Are they really equal? So is 7 squared plus 14 squared equal to 16 squared? So I have a little math to do here. So is 49 plus 196 equal to 256? So 196 plus 49 is 245. So this turns out to be, is 245 equal to 256? My answer is no, so it's not a right triangle. So then I have to go back and say, looking at my two rules, is the a squared plus b squared bigger than c squared? Is this bigger than that? The 256? No. Is this less? Yes. That means that what's happened is that the c squared's gotten bigger, so angle c has gotten bigger, which means that we have an obtuse triangle. When I compare in question number 2, is this a triangle? It means is 3 plus 5 greater than 9? Is 8 greater than 9? No. So this is not a triangle. If it's not a triangle, then part B doesn't make sense. And I'll give you an example that will help you understand that. If somebody was to ask me if I had, or ask me what kind of dog I had, that would be a silly question without first asking what kind of dog, or if I have a dog. So in part A, if I don't have a dog, you can't answer what kind of dog it is for part B. So if this is not a triangle, I can't tell what kind of triangle it is in the next question. In part 3, I have to test to see if it is a triangle. So is 10 plus 24 equal to 26? I'm sorry, greater than 26? Is 34 greater than 26? Yes. So this is a triangle. Then I have to tell what kind of triangle it is. So I'm testing the a squared plus b squared. And I'm testing to see if it's equal, or if a squared plus b squared is bigger, or if it's smaller. So this is 10 squared plus 24 squared equals equals 26 squared. So this is 100 plus 576 equals 676. And I get 676 equals 676. And it's equal. Our rule up above says if it's equal, that we have a right triangle. Question 4, the last one, might be the one that's kind of the most difficult only because there's radicals in there. But I want to check first of all and find out, is this a triangle? I don't know which of these is the largest side when there's radicals in there. So I have to go in on my calculator and find out what 2 times radical 3 is, which is about 3.46. 4 radical 2, and I'm typing this on my calculator right now, 5.66. And then 3 radical 5, 6.71. Those are rounded, but at least it gives us a good idea. So I have to see if the 2 smaller add up to be greater than the third. When I'm adding radicals, that doesn't really give me a great idea either, but if I have 3 point something and 5 point something, this is at least 8 point something, which is bigger than what we know 6.71 is. So yes, this is a triangle. To test the kind that it is, means I substitute into Pythagorean theorem. So I'm going to put those side lengths in. I'm putting in 2 radical 3 and squaring it. 4 radical 2 and squaring it. 3 radical 5 and squaring it. Go back to your rules for radicals. 2 radical 3 squared is 2 radical 3 times 2 radical 3. I square this one. And I get 12 plus 32 equals 45. When I add those together, I get 44 equals 45, which is not true. BA squared plus B squared is less than C squared. That means that angle C got bigger than 90. If angle C is bigger than 90, then I have an obtuse triangle. So I put it right back to the comparison with the rules up there. This is the last day of new notes for this unit. Tomorrow and the next day are a review followed by a test. Make sure you pay close attention when you're doing the review sheets. For the test, remember there's a direct parallel between knowing how to do the review sheet and doing well on your test. In addition, please get your notes ready to turn in. I will be collecting those on the review days, the day of the test at the latest.